friends, it's Mark Weller with My EV Mechanic, and today we are reviving these dead Tesla modules. All right, so we're going to go ahead and describe the full process for bringing these modules back to life if we can. So it wouldn't be a discussion about high voltage if we didn't address some of the safety issues. So part of the procedures that we're going to be doing here, there's an element of risk. It's what it is. You want to make sure you're wearing your safety glasses, have your high voltage gloves. You want to have a buddy handy and not be working alone. You want to not leave your project unattended. And in the event something goes awry, you want to be able to get yourself and the vehicle outside. All right, so there's going to be two ways that batteries can fail, kind of two classifications, if you will. So if you have a vehicle that you've been driving regularly, everything is fine, and all of a sudden you get the orange triangle of death, that's going to indicate that there is indeed a problem with a particular battery, that it has fallen out of spec with the other batteries, and so this process of reviving them probably is not going to work. There probably is something actually defective with the battery. The second problem I'm going to call a slow death. So a slow death is going to occur when everything was working fine and the vehicle, or in this case our trainer cart, it's sat for an extended period of time and the battery has slowly lost voltage. Okay, so that's what we're going to work on today, is we're going to attempt to bring the voltage back up. So the first concept we need to get across is evenness is key. So a battery pack is made up of several modules. Each of these modules is approximately 25 volts, and they're connected together in series to make up 100 volts. We want to keep the difference between modules under half a volt. Now within an individual module, we have cell groups. These are individual cells connected together in parallel to make up a single unit. We have 6 of these cell groups within each module. We want to keep the difference between cell groups under 50 thousandths of a volt. Ideally, we want to keep that to 0.025, okay? 25 thousandths of a volt difference between cell groups. So we would refer to this as a tight pack, okay? You could also call it, if you want, we could call it a tight box. So that's what we want. That's what we're looking for. So we use the battery management system to help make sure that all of our cells stay within our safe range. So the battery management system is a pretty fragile unit. And so we talked about our evenness. So when things get uneven, the battery management system is at risk, at great risk, because the resistors that are inside there are very delicate and they burn out like very easily. So for that reason, the first thing that we want to do when we're doing this procedure is we are going to unplug our BMS. Then you'll want to shut off the manual service disconnect to isolate the battery from the rest of the system and install your lockout tagout. So for your Tesla module, they're in groups of 6 per module. For each individual cell group, our magic numbers are going to be, our top voltage is going to be 4.2 volts. Our nominal voltage is going to be 3.65, and our bottom voltage is 3.3. Okay, so whenever we go in any one cell group below 3.3 volts, we are at risk that this module is never coming back. Now, what I have found is a pretty high percentage of the time, they actually do come back. So we unplugged the BMS because we are going to artificially charge each module by itself. Once we're above this 3.3 level, at that point we can go ahead and plug the BMS back in and charge it like a normal, like it was designed to do. To charge up our individual modules, we're going to be using this power supply. And these are pretty common power supplies. They They actually use what's called CCCV. I'm going to describe that in a minute. But so we have adjustments for voltage, and there's coarse and fine. Amperage, you'll have the same adjustments, and you'll need to make that after it's connected to the battery, as you will need to have a load to see what the amperage actually is. Okay, so to describe the constant current, constant voltage, if I have a glass and the glass is empty and I fill the glass, I can fill this glass as fast as I want to get the glass to fill up. But as soon as I get near the top here, I'm going to have to slow it down. So this is going to be the CC is constant current. Okay, so we're gonna do constant current until the glass gets almost full, and then we're going to change to CV, constant voltage. And the constant voltage is going to be just for this last little bit right here. So if this was a soda, like if you're filling it fast, then it would get this foam head on it, and then we would need to slow down the current. So when I am charging my batteries, we're going to use our power supply to bring the batteries up to the minimum of 19.8, and that's what we're going to do in this next section. So I'm going to turn the power supply on. We want our power supply to be even-ish with the module before we connect it. I'm going to start with module number 2. So we are at 12.21. I'm going to set my power supply to half a volt higher. So we're going to bring these up very, very slowly. So even though the modules are connected together in series, we're only connected to this individual module. And just as a reminder, the BMS is unplugged at the unit. So I'm going to come over here and I'm going to use the coarse adjustment to dial this back to 12.75. Right around there. Okay, that's going to be close enough. Okay, we're a half a volt over the current voltage of the module, but we would never take the module over the maximum voltage for the whole module. We would never do that. That's how you create a fire. So we are just slowly walking this up to the minimum voltage for the module. So we're going to go ahead and connect up here, and we will see we're now, so it brought it up to the 12.82 is what we're putting in. And you're watching the amperage doesn't go above 5. I'm okay with that. So I'm going to bring it up. So our module is coming in around 14 volts now, but the amperage is still relatively low. So we're going to go ahead and dial some voltage in, which will bring up the amperage as we're in the constant current. And then we'll go ahead and stop around 5 amps. We're going to let that sit right there for just a minute. We don't want to connect unless we are within half a volt. We don't want to go ever above 5 amps. And whenever this walks down and it's at half an amp, then we can go ahead and raise the voltage and bring the amperage back up so that we're still filling the battery. So this is what one that will come back to life is going to look like. So we're going to take a look at what a defective module looks like, so you know how to diagnose that. So I'm using a proving unit to make sure that the meter works. So it's sending out 240 volts. So there it is on the meter, 240. Now I'm going to go to the module and measure the voltage there, and this module is going to be showing 0 volts, straight up dead. So I'm going to bring the voltage down as I'm going to disconnect from the other module. So I'm going to bring that down. I'm putting in 0 current. Now I'm going to disconnect. So it's at 8 volts. I'm going to set it to just 1 volt. So we'll set it there. Okay. I'm going to connect my power supply to module number 1, which we already know is defective. So we're sitting at 1 volt. We're pulling 4 amps. And so what we're going to find is that it is going to just sit at 4 amps indefinitely. That's how we'll know it's bad. So I'm going to replace this module here, the number 1 module. I'm going to put in, I have another module I'm going to put in there. The other modules, they are going to come back to life. So we are now through the magic of video. It is now a couple days later. So I have been nursing the pack along for several days. We have had our power supply connected, and now we're getting about 21-ish volt. There were a couple. This one here is still a hair high, so 22.42. So the difference between these two, that's higher than what you want. We want those closer. I wanted to get the video done, so we're going to roll with it. So we're going to come up here now. So, and I've already pre-tested everything here. So you want to use your BMS harness tester to check and make sure your voltages are within 50 thousandths of a volt, and then go ahead and plug in the harness. All right, and then we can now turn our disconnect, remove this, and turn this back on. And so now we are going to connect to the laptop and see how things look. So we're going to go ahead and we're going to be using this program called Putty. And enter. Okay, there we go. And so these are our cells now that we've brought all of the voltages up. So you can see the one module that I replaced, the voltage was much higher. So there are two ways that I can correct that, and it's close enough that I felt it was okay to plug in. That's about as far out as you would want, though. So you can either connect a load, put a load on the battery, like I connected the two 12-volt lights in series and put a load on the battery. It actually needed to bleed that down longer. Or the other three modules, I could bring those voltages up higher. But ideally, they should all be closer than this. All right, well, I want to thank you for watching along with me. I hope you learned a little something. Make sure you tell your friends EVs are now available for everyone. And I look forward to seeing you in a future video. If you have not already subscribed, please do. If you're one of my followers, thank you. And I'll see you around the EV circuit.